Hello students, today we are going to discuss a very important topic, that is Kirchhoff's law. You will definitely get 5 to 7 marks question from this topic in your board exam, and this is very important as far as JEE Mains and NEET is concerned. So we'll start with this important topic, Kirchhoff's law. Kirchhoff's law has following two laws, but first of all we'll discuss with the first law, and that first law is also known as point rule or junction rule. It states that the algebraic sum of current meeting at a point is zero. ये एक पार्ट ऑफ इलेक्ट्रिकल सर्किट है. यहाँ पर जितना करंट अप्रोच करेगा पॉइंट P में, उतना ही करंट पॉइंट P से निकलेगा. And that is what it says. The algebraic sum of current meeting at a point is zero. So the current that is approaching the point will be taken with positive sign, and the current that is receding away from the point will be taken with negative sign. So you can see I have written plus I1 plus I2 plus I3 because they are approaching the point, so they are written with positive sign. Now I4 is receding away from the point, so written with plus minus I4. I5 is also receding the point, so plus minus I5 is equal to 0. And here, so we can write I1 plus I2 plus I3 is minus I4 minus I5 is equal to 0, which can also be written as I1 plus I2 plus I3 is equal to I4 plus I5. So that is what happens. Whatever current comes to the point, the same current will recede from the point P, which is also written as summation I is equal to 0, and this is the mathematical form of Kirchhoff's first law. This first law is also said to be the law of conservation of charge. Hopefully you have understood this law. Now I'll discuss one question normally comes from this first law. The question is, find the value of I in following diagram. Here you see 3 ampere, 4 ampere, 2 ampere are approaching the point P, and 5 ampere, I and 2 ampere are receding away from the point. So we will write 3 plus 4 plus 2 minus 5 minus I minus 2 is equal to 0. And therefore this 3 plus 4 plus 2 becomes 9. Minus 5 and minus 2 becomes minus 7, and this minus I. So therefore this 9 minus 7 is 2, 2 minus I is equal to 0, therefore I is equal to 2 ampere. So using point rule, we have obtained I as 2 ampere, and this is how you can solve this type of question. Hopefully you have understood the first law. Now we will going to discuss Kirchhoff's second law. So this second law is also said to be the loop rule or mesh rule. और इस रूल को कुछ ऐसा स्टेट किया जाता है. The algebraic sum of potential drop across all the circuit element round a closed loop is 0. Here we normally come across two circuit elements, that is a resistor or a cell. Beside this you can have capacitor, inductor, anything, but time being will be concentrating only on resistor and your cell. So see, we have certain assumptions, and assumptions are like this. If you have a resistor and if this is the direction of current, and if you are moving along this direction, that means if you are moving against the direction of the current, then the potential drop IR is taken with positive sign. अगर आप along the direction of current move कर रहे, then the potential drop को minus sign से लिया जाता है, that is minus IR. If you are moving from negative to positive terminal, this direction from negative to positive terminal, then you are taking E with positive sign, and if you are moving from positive to negative, you are taking with minus E. So this rule you follow properly. Some books may do the assumption in the different way also, but whatever you follow the same one. So you understand here that if you are moving in this direction, that means against the direction of current, that means you are moving from lower to higher potential side, and this potential drop IR is taken with positive sign. Here you are moving along the direction of current, that is moving from higher to lower. So therefore minus IR. Here also from negative to positive plus E. From positive to negative minus E. This rule you follow properly, you'll get the answer absolutely correctly whenever you are solving any question. So let's apply this second law in one of this question. Here you see it is said, find the current in the circuit. इस करंट में हमको करंट को निकालना है, सारा चीज दिया हुआ, तो इसमें हम लोग लूप रूल लगाएंगे ऑन द लूप ए बी सी डी ए. दिस लूप में हम लोग लूप रूल को लगाएंगे. So first of all, we'll be going from A to B. As we go from A to B, we first of all encounter this 10 ohm resistor. And जैसे हम लोग against the direction of current move कर रहे हैं, तो this potential drop 10I will be written with positive sign. When you are moving this, you are moving from positive to negative. Therefore, we'll write minus 20. See, positive से negative minus C. So when we are going in this direction, positive to negative minus 20. Here we are moving from negative to positive, therefore plus 10. Here we are moving again, see, against the direction of current, so that becomes 5I, and back to the same point, so that becomes equal to 0. So this 10I plus 5I is 15I, minus 20 plus 10 becomes minus 10, and that equal to 0. So we can write 15I is equal to 10, and therefore I is equal to 10 by 15, and that is 2 by 3, and therefore current here becomes 2 by 3 ampere. Hopefully you have understood how this rule can be applied. If you apply this rule properly and solve the equation, you can solve any type of question from Kirchhoff's law. Yes, we are going to take up another question. Please see, this question reads, find the potential difference VA minus VB between the points A and B in the figure given below. This is the figure. This is VA, current is 2 ampere, this resistance is 2 ohm, this is 3 volt EMF, and this is 1 ohm resistor. You have to find the potential difference between point A and B. We will apply Kirchhoff's law along this path. So along this path we are applying Kirchhoff's law. So what happened? VA, you are moving along the direction of current. Therefore the product 2 into 2 becomes negative. Current into resistance negative, because you are moving along the direction of the current. Here we are moving from positive to negative terminal. That's why minus 3. Here we are moving again along the direction of the current. So the current into resistance is minus sign, minus 2 into I, back to the point A, and therefore that's equal to A, VA. Back to the point B, and so this point becomes equal to VB. And therefore VA minus 4, minus 3, minus 2 is equal to VB. And therefore VA minus 9 is equal to VB, and therefore VA minus VB becomes 9-fold. You may get a question like this. So this is how you're going to solve it. Yes, now we are going to take up one question on Kirchhoff's law. हाँ देखिए, क्वेश्चन रीड कर रहा है, यूजिंग Kirchhoff's law, solve for I1, I2, I3 in following figure. So this is the figure given to you. Now in order to find current I1, I2, I3, this is I1, this is I2, this is I3. First of all, we'll apply point rule at point C. So if you apply point rule at point C, then I1 is approaching the point, I2 is approaching the point, and I3 is receding from the point. Therefore, I1 and I2 will be taken with positive sign, and I3 will be taken with negative sign. So I1 plus I2 minus I3 will be equal to 0, which can be written as I1 plus I2 is equal to I3, and this I mark as equation number 1. Next, we'll apply loop rule to the loop. A, B, C, F, A, this loop. So this loop we will be applying the loop rule. So this is how we are marking. We are going from A to B. So as you go from A to B, you encounter the first element, that is the cell which is of 14 ampere moving from positive to negative and therefore minus 14. Next, you encounter this 6 ohm resistor. You are moving against the direction of the current, therefore 6I1. Third element is the cell. We are moving from positive to negative, therefore minus 10. Next, we have this 4 ohm resistor. Again, we are moving along the direction of the current, so it is minus 4I2. Back to the same point is equal to 0. This can be written as 6I1 minus 4I2. This minus 14 plus 10 minus 10 becomes equal to minus 24. I take it to the other side and it becomes 24. I divide the whole thing by 2. So this becomes 3I1 minus 2I2 is equal to 12, and this I mark as equation number 2. Next, I take the big loop. A, B, C, D, E, F, A. The whole loop I consider. This whole loop I consider. So see, A, B, C, D, E, F, A. This loop. So first of all, you are moving along this direction from positive to negative. Therefore, minus 14. Here you are moving along the direction of the current. So minus 2I3. Then you come to this, again you are moving along the direction of the current, so minus 4I2 is equal to 0. We'll put the value of I3, which is I1 plus I2, and we'll take this 14 to the other side. So it becomes minus 2 I3 is I1 plus I2, then this minus 4I2 is equal to 14, which can be further written as minus 2I1 minus 2I2 minus 4I2 is equal to 14. And that can be written as minus 2I1 minus 6I2 is equal to 14. Divide both the side by 2. So it becomes minus I1 minus 3I2 is equal to 7. This is equation number 3. I'll be solving equation 2 and 3 simultaneously. So what I do, I multiply equation 2 by 1. So it becomes 3I1 minus 2I2 is equal to 12. Then I multiply equation 3 by 3. So it becomes 3 minus 3I1 minus 9I2 is equal to 21. You just add it up. I1 gets cancelled. So minus 2 minus 9 becomes equal to minus 11I2, which is 33. And therefore I2 is minus 3A. Put the value of I2 in equation number 3. So it becomes minus I1. Minus 3 into minus 3 is equal to 7, and therefore minus I1 plus 9 is equal to 7. Therefore minus I1 is equal to 7 minus 9 is equal to minus 2, and therefore I1 is equal to 2 ampere. You get I1 is 2 ampere. I have got the value of I2 and I1. I'll put it here in equation number 1, and therefore I3 becomes I1 plus I2, that is 2 minus 3, and therefore I3 is equal to minus 1 ampere. So this is how you get the value of I2, I1 and I3 using first of all Kirchhoff's point rule here, then this loop, and then this loop, solving the equation 2 and 3 simultaneously. You can easily get it. So apply Kirchhoff's law properly and then solve the equation properly, and as a result you can get the values of current I1, I2 and I3. Hopefully you have understood this question.